Greetings everyone. This project is developed in order to benefit patients who are bedridden and can't speak. For example, a paralyzed patient. For the project demonstration, we have a patient who is suffering from paralysis. So according to a report, there are around one person in every 50% who is suffering from paralysis. For patients in such conditions, it is very difficult for them to communicate. Even trained nurses and doctors are not able to examine them and understand their needs. This makes patients develop mental stress, which hinders in their recovery. So, in order to communicate easier and understand, our team came up with a project Saathi 2.0.
There are two different technologies for communication purposes. First one is brain computer interface BCI devices and second is eye tracking devices. Brain computer interface devices makes easier the development of the task and produces less frustration for the user. But the disadvantage is that it requires high amount of mental attention which is generally not expected from a paralyzed patient. Other technology is eye tracking devices, which requires only the movement of eyes. Till now, the most prominent device in the market is Tobai Eye Tracker. This tracker uses pupil coordinates to control the UI. The advantage is that it gives the high accuracy and easy to use. But the problem is cost is really high. It's more than $10,000 and most importantly UI available with most of the eye tracking devices consist of only keyboards which usually take more than 2 minutes to communicate a single sentence and it also requires a more effort for this communication. So now we have our project.
The project is coupled with an eye tracking system and a screen. The team redesigned the traditional way of communication and developed a new framework which was easier to use. The framework is the tab tree structure. Patient can communicate most of the things with this tab tree structures with a maximum of 3 clicks. So this is the main UI of our Saathi project. It is equipped with an SOS button in case of emergencies. It will send messages to reception, to doctor, to nurse and the family. Then we have the eye writer, which helps in the tab tree communication of the paralyzed patient. Then, if in any scenarios the tab tree structure is insufficient, we have an keyboard with us which is equipped with auto suggestion, and then we have home automation also. Patient wants to control the fan, the light, the curtains. He can control all of them with help of this tab. Here is the live demonstration of the project. The patient will now communicate through the iWriter tab. He will select it from the main GUI. Now, the main GUI is open and the patient will communicate with the help of this tab. You can see how the patient is using his eyes in order to control the GUI. Here, the patient called the doctor. Yes, Navneet, you called me. How are you feeling? The patient can answer the doctor using our tab tree structure. Here, the patient selects OK under quick answers. Okay. Okay, so you call me. Do you have any pain? Uh, you can take your time and answer me. Do you have any pain? We have a dedicated tab for pain. The patient can select under that tab which type of pain he is suffering from. So you have back pain. Okay. Can you please tell me for how long you have been sitting in this posture and in this position without any movement? You can tell me number of hours. How many hours you are in this same position? The patient can answer this question with the help of number tab in our tab tree structures, which is designed for to answer these type of questions. 5 hours. This is a bit too much. I will send the nurse and she will change your position and she will take care of the condition. What is happening? I will send the nurse. Now, live demonstration of the home automation system, which is also a part of our project. The patient will select home automation from the GUI. Here you can see the patient has clicked on the light off button and the light will switch off. If the light is already off, it will switch on. And now you can see how the patient opens the curtain.
Most of the time, the patient will sit in front of the screen, so it may affect the eyes of that patient. So, to provide some basic functionalities like accessing tube light or fan or AC or maybe curtain control, so we have provided a Li-Fi receiver. You have to just connect the appliance. Like this is a table lamp. Now we'll show you how to control this using Li-Fi. Now just connect that to this socket provided. So we have a patient with us. Firstly, we need to make a gesture to turn on the laser so that we can transmit the data. So there we have a receiver system of Wi-Fi, and here we have a smart glasses that will be on the head of patient. So we have a laser equipped on the smart glasses. Firstly, patient will make a gesture of tilting his head towards left and then towards right. Now we can see that lasers turned on and it turned on the appliance. Now laser will turn off because we have to take care of the safety of other people as well. Now we'll show you how we can turn off the laser, turn off the appliance. Now laser again started. We have to point towards the receiver system.
Live demonstration of the keyboard. Here, the patient will type a sentence, want to meet my son, with help of this keyboard. This is not a traditional keyboard. It is a keyboard which is redesigned and it is now equipped with auto suggestion. Here you can see how after typing want to automatically came and the patient selected it. Now you can see how TA is typed and talk is now here. So the patient can select talk. Now this helps in reducing the number of selections and the number of clicks. The cursor is controlled using head movement. Head movement is captured with help of the smart glasses the patient is wearing. This keyboard is really easy to use with help of this auto suggestion that is linked with it.